Okay, so welcome to day 2 of probability distributions. Today we're going to be looking at uniform probability distribution, which will be the easiest one to look at. The simplest distribution is the one in which each outcome is equally likely. Okay, so if they're equally likely, that's going to be the same. We're going to call that uniform. So a distribution in which all outcomes are equally likely in any single trial, we call this a uniform probability distribution. A uniform probability distribution. So remember that all probabilities have to add up to 1. So we take that probability that adds up to 1. And if there were 3 of them, then it would be 1 over 3. Each outcome would be 1/3. The probability of each outcome would be 1/3 if there were 3 possibilities. If there's 10 possibilities, it's going to be 1/10. If there are n possibilities, then it's going to be 1 over n is the probability of that individual outcome happening. If we think about this, if we say that this had a value of 1, if we divided this up into n segments, then each segment itself is going to be 1 over n. So this is the idea here. We're taking our probabilities, which have to sum to 1, and we're dividing them into n options, and each one is equally likely. So once again, the sum of the probabilities has got to add up to 1. This is always the case. So we're going to be taking this, basically applying the same thing that we did yesterday, but in this particular case, in every instance, the probabilities are going to be equal. So it should be even easier than what we looked at yesterday. In this case, if we're looking, draw the probability distribution graph for rolling a single die. So we know that there are 6 possible outcomes, a 1, a 2, a 3, 4, 5, or 6 on the dice. So the probability for 1 over 6 is going to be, the probability of getting a 1 is 1 out of 6, of rolling a 2 is 1 out of 6, a 3 is 1 out of 6, a 4 is 1 in 6 chance, a 5 a 1 in 6 chance, and a 6 a 1 in 6 chance. So I'm going to draw a graph. This is my probability distribution graph. Probability distribution for rolling a die. For rolling a die. Our probabilities exist on our y-axis, and the face value, the face of the die, is on our x-axis. So if we say go up by 1 over 6, we're going up by 1, 2, 3, going up by 5. 2 out of 6 are probabilities for a 1, a 2, a 3, a 4, a 5, or a 6 are all 1/6. And we can draw lines for that if we so choose. Makes it a little bit easier to see the points. Okay, so this question just asks us to draw the graph, and so we've done that. Moving on to page 2, we're given a situation where a woman has 16 units of framing to enclose a rectangle. The width of the rectangle is chosen randomly, and only integer widths are to be chosen. So what is the expected width of the rectangle? So we're told that RV, let the random variable x represent the width of the rectangle. So I'm just going to draw my rectangle. I'll call this one my length and this one my width. At a minimum, given that our units have to be an integer, the smallest length I could have would have a value of 1. If the length had a value of 1, I've got 2 lengths. That's going to sum to 2. And so 16 subtract 2 will leave me with 14 units to use, and that width is going to have to be divided by 2. If I had a situation where my length was 1, then my widths would be 7. That's going to be the longest width that I can have. So I'm going to have a possible width of 7, and then anything smaller, a 6, a 5, a 4, 3, 2, 1. So this is So this is our index value. This is the first time we've written a table like this. So the actual length, the actual width of our fence in this case, in the first instance, is going to be a width of 1. And given that this is chosen randomly, there's no reason to say that any particular width would be more frequent than another. So we can assume that this is going to be a uniform distribution. So the probability of having a width of 1 would be 1 over 7. For a width of 2, a width of 2 would be 1 over 7. A width of 3 would be 1 over 7. A width of 4, equally likely. All of these possibilities are equally likely. So our probabilities are 1 over 7. In this case, we're not asked to graph it. We're asked for the expected width. So we remember that our expected value, the formula for that is the sum of I equals 1 to n of the expected value times the probability of that expected value times the probability of my expected value. So in this case, I have 7 values that exist. I've got a 1, which has got a 1 and 7, with a 2, which has a probability of 1 and 7, with a 3, with a probability of 1 and 7, with a 4, with a probability of 1 and 7, with a 5, with 1 and 7, with a 6, with 1 and 7, and a width of 7 has a 1 and 7 probability. We can sum these to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all over our value of 7. We do that, that gives us a value of 28 over 7, or an expected value of 4. Finish with the concluding statement. Therefore, the expected value is 4 units. Okay. Just a reminder, if you've got questions from the previous day, send me an email and I'll be happy to answer those. We'll do one more question. I'll put that on the next video so we don't run out of time.